Alright guys, so you should be watching this after you're done with your pre-test. You are going to watch this video, you're going to take notes on the piece of paper that we provided you, and then when you're done, Mr. Hernandez and I will be walking around helping you guys with your homework. Pause anywhere that you need to, so that you can write down, re-listen if you need to for explanation, and then like I said, when you're done, we will go through and answer any questions that you guys have in your homework. So, last unit we spent a lot of time talking about key features. We're going to build onto that, and we're going to talk about a few new features between today and tomorrow, and then on Friday we're going to talk about a few more key features. So we've already done increasing versus decreasing, x and y intercepts, domain and range. We've talked about asymptote, but we haven't written it, so we're going to write an asymptote. We're going to talk about minimums and maximums, and then we're going to talk about where a function is positive. Okay, so if you take a look at your notes, what we've talked about already, whether a graph is a function or not, that just comes from the vertical line test when it's graphed. So vertical line test. We've talked about linear versus exponential, showing that linear is a straight line and showing that exponential is a curved line with an asymptote. Domain versus range. Domain is your x values. How far left or right your function goes. Range is your y values, which means it's how far up or down your function goes. Intercepts are just saying where you're hitting the axes. So where you're hitting the x-axis and where you're hitting the y-axis. Alright, so that's all review. Right, let's talk about your new features. So one of them is an asymptote, and we've talked about this before, but let's actually put a name to it. So an asymptote is a line a graph approaches but never touches. And we are only going to be dealing with horizontal asymptotes, which means that our line will always be written as y equals something. Okay, and because it is a line that we approach, we must write it as y equals. So for instance, in this problem to the right, you can see it looks like you're touching this, but because we know it's exponential, we know it doesn't actually touch this, and we can see that it's a height of 2, so we would say that this function approaches the line y equals 2, but it never touches it, so your asymptote is y equals 2. For this equation, again, it looks like it's touching here, but we know because it's exponential, it's not actually touching that height. That height is 0, so it's approaching this line of y equals 0, but it's never touching it. Okay, again, horizontal lines are y equals. Alright, next, an increasing function. So an increasing function, as the x values increase, the y values also increase. That just means your height. So I can see that as I go from left to right, my function's going up, and I can see as I go from left to right, my function's going up. So that's an increasing function. On the other side, I can see that as I go from left to right, this function's going down, and so is this function. Therefore, decreasing is as the x values increase, the y values decrease. So, an increasing function versus a decreasing function. The y value, sorry, decrease, not plural. Okay, minimum. Minimum is the lowest point of a function. So we can see right here that this is the lowest my function will ever reach. This is the lowest my function will ever reach. A minimum is a height, so we use the y values of the coordinate. So we can see that here this coordinate is 0, -2, which means this is a minimum. We can just abbreviate to min at -2. Okay, this one, the last one was an equation. This one is just a value. The lowest height that it will reach is -2. This one is a min at, and you can see that this is your height right here, so it's a minimum at 1. On the other side, we could then have a maximum. So a maximum is the highest point of a function, and the maximum is a height, so we use, again, the y values, minimum, maximum, or heights. Alright, so if we take a look at our graph, you can see this arrow means it's going to go down, so we don't know what minimum it is because it's going to continue going down, but we can see that this is the highest height, so we're going to have a max at, what height is that, 1, 2, 3, so it's a maximum at 4. This one we can see that this is going to continue going down. It is going to reach this asymptote, but it's going to keep getting closer and closer and closer, so it doesn't actually stop getting closer to -2. But we can see that at the highest height that it will reach is 6, so we would say that it has a max at 6. Okay, and then this is probably one of the most difficult topics, is where a function is positive. That means the x values that make the function be above the y-axis. So what this means is anytime a function is above the y-axis like this, it's positive. Anytime you're below the y-axis, you're negative. And we're not actually going to ask for negative, we're only going to just say where's the function positive. And when we say this, we're asking for what x values make the function be above the y-axis. So we can see that my x values start here. So from this x value, as I continue to the right, I will always be above my x-axis. So this function is positive for all x values greater than or equal to -3. Any x values that are negative, greater than or equal to -3, I will be above on my function above the x-axis. This one over here, you can see that your domain is going to continue going this way forever. You're never going to go below this line. So if you're never going to go below this line, you're never even going to reach negative. And this never stops like this one did, so this means you're positive for all real numbers. There's not an x value that would make you go below your y-axis. Every x value will make you be above your y-axis. Okay, so now that we've talked about those, let's actually just go through a bunch of examples and see how we do with this. Alright, so first off, this is a curved line, so it's exponential. The function, as I go from left to right, I can see I'm going up, so it's increasing. The x-intercept, it never hits the x-axis, so there is none. My y-intercept is right here, so that's at the coordinate 0, 3. The domain is talking about my x values, so on my x-axis, this is where my function starts, and then it continues to go this way, so that's greater. So my domain is x is greater than or equal to 0. My range is talking about my height. Well, this is where my height's starting, and then it's going up forever. So the range is all y values greater than or equal to 3. There is no asymptote because of the fact that we put a point here and we stopped it, so there is none. And if we take a look, my function will continue going up, so I don't know how high it'll reach because it'll go up towards infinity. But I do know that there's a minimum, and it's at the height of 3. Okay, so notice how we've written each of these. This one was written as an intercept, so a coordinate. Domain, range were written as inequalities, and then the minimum was written as a value. So a lot of differences between these. Okay, let's try another one. Alright, number 2. This function, as I go from left to right, is going up, so it's increasing. It hits my x-axis right here, so that would be at 2, 0. It hits my y-axis right here, so that would be at 0, -3. The domain is talking about my x values. Well, left and right, I'm going to continue to go left here. This function continues to go right, so my domain is all real numbers. It doesn't stop going left or right. Range is my height. I can see that my height's going to continue going up forever, but it's never going to go below this asymptote. It's going to approach it, but it'll never go below it. So that means my range is all values that are greater than, where's that asymptote at? 1, 2, 3, all values, all heights greater than -4. Notice I did not say equal to, because then that means it hits the line. Right? And then my asymptote is the equation y equals -4, which these will then always match. Okay, again, equation y equals. This does not have a minimum because it's going to keep getting closer and closer to -4. It doesn't actually stop, and it doesn't have a maximum because it keeps going up forever towards infinity. So it's got no minimum or maximum. Okay, and then lastly, where is it positive? Where it's positive is asking where it's above the x-axis. Well, right here is where it starts being above the x-axis. So at 2, it's not above the x-axis, it's not below the x-axis, so it's actually not positive or negative. It's neither, but anytime we get greater than 2, when we get to 3, we get to 4, we get to 5, then it'll always be above. So I just want to say, again, x values, I want to say when x is greater than 2. I don't want to say equal to, because when it's equal to 2, it's not above or below. Okay? Alright, let's try another one. Different color here. Okay, number 3. So, make a point right here. This is where your function stops because there's no arrow. I can see that as I go left to right, my function is falling, so it's actually decreasing this time. My x-intercept is at 10, 0. My y-intercept is up here at 0, 4. My domain is my x values. Well, here's where my x value never goes past, and then my x values go this way, which is less than, and then it continues going that way. So my domain is all x values that are less than or equal to the value of 10. Range is my height. The lowest that my function reaches is this, and then my function will go up for forever. So my range is y is greater than or equal to 0. Okay. There are no asymptotes because this is a linear function. There is a minimum, and it's at a height of 0. This is a minimum right here. It's got no maximum because it keeps going up, but I do know the lowest height it will ever reach is 0. Where it's positive, it's actually positive for almost its entire function because all of this is above my y-axis. It starts being above, oops, sorry. It starts being above right at, oh my gosh, right at this value right here. It's not positive there because it's not above the x or the y-axis, sorry, the x-axis, but it is going to be once I get less than. So it's positive for all x values that is less than 10. Because you can see at 9 I'm above, at 8 I'm above, at 7 I'm above, at 0 I'm above. I'm just not above at 10. So anything less than 10. Alright, let's try another one. Number 4. Okay. This right here, you guys can put a point since there's no arrow. Let's assume that that's stopping. As I work from left to right, this is decreasing. I can see I hit my x-axis right there at negative 2, 0. I can hit my, or I end up hitting my y-axis right there, which is 0, negative 3. My domain is starting from this x value and then going this way. So negative 3, and it's getting greater. So all x values greater than or equal to negative 3. Alright, now this line right here is what my function is approaching but not touching, even though it looks like it. But we know because it's exponential, it's not actually going to hit it. So my range is actually going from the height of negative 4 to the height of positive 4. Okay, I can see I'm going from here all the way up to here and everything in between. Range is my y. But here's the thing, at negative 4, I don't actually hit it, so I just want to say less than. But at 4, I hit that value, so I want to say less than or equal to. Okay, so compound inequality between negative 4 and 4, including 4, but not including negative 4. The asymptote is at y. Oops. The asymptote is at y equals negative 4. There is no minimum because it keeps getting lower and lower and lower, but there is a maximum at a height of 4 right here. So we want to then say max at 4. Where's the function positive? So again, what x values make my function positive? Well, from here all the way down, I'm negative. So positive would be from this x, would be this right here. So what x values make me be above? Well, at negative 3, I'm above. And at negative 2, I'm on, so in between those. So I'm actually saying I'm positive from negative 3 to negative 2. I'm talking about my x values. At negative 3, I'm above, so equal to. At negative 2, I'm not above, so just less than. Okay, so a lot of compound inequalities. Okay, talk about number 5. Number 5, we have some context. Time on your time in seconds versus height above the ground. So you can see that you're lowering, so this function is decreasing. Your x-intercept is right here at 30, 0. Your y-intercept is all the way up here at 0, 7,500. The domain is your x values. My x values are going from 0 all the way to 30. So my domain is from 0 to 30. It's talking about my x values. At 0 there is a point, and at 30 there is a point, so I want to include both of those with equal. My range is my height. So my height is going from here all the way up to here. So from 0 to 7,500. So all values between 0 and 7,500, talking about y, I have a height of 0 and I have a height of 7,500, so in those cases I need to equal for both. Okay. My asymptote, there is none because this is a linear function. There is a minimum, and again, height. Minimum, my height is 0, and I also have a maximum height of 7,500. Notice I'm only looking at my y-axis. So this means I'm going to say min at 0 and max at 7,500. Okay? My function is above the x-axis. Notice there's no arrows. My function is above the x-axis for x values from here all the way to here, but not at 30, because at 30 I'm not above, I'm on. So that means I want to say my function is positive from 0 to 30, talking about my x values. At 0, I am above, so equal to, but at 30, I'm not above, so just less than. Okay, so if you take a look at what we just talked about, there's a lot of specific ways that we have to write these, and unfortunately, if you write them any other way, it's not right. So your x and y intercepts have to be written as coordinates. We practiced that. Your domain and range sometimes will be written as inequalities. These were all pretty much written as inequalities, except sometimes they're compound. This would be a compound because there's two things happening, and then this over here would not be a compound. Okay? Asymptotes have to be written as lines like this, y equals. Minimums and maximums, you have to state what it is. So a minimum at a height of 0, a maximum at a height of 7,500. It's implied that it's a height, so we're talking about looking at our y-axis. And then where the function is positive means what x values are going to make you be above the x-axis. Okay? So, your homework is to show us that you got your notes done, and then we will give you number 1 worksheet. Make sure that when you're looking at your answers tonight, you're looking in Unit 2B, since this is the first day of the new unit. Okay, your homework's going to look like this. It's 3 pages. It's a lot of the same questions over and over and over again, but just slightly different. So make sure that you're looking back at your notes. If you have a question, you can ask us. We'll be moving around, checking how you guys are doing. Okay? All right, thank you.